Okay, thank you for coming in here. As soon as you're all quiet, I'll start. Okay, thank you. Okay, so we are here today for our keynote for our SIR IMSAloquium, and it is my pleasure to introduce Dr. Angel Alvarez from Northwestern University Feinberg School of Medicine, and I let him take it away. So, go for it.
Thank you so much. It's a great honor to be here, although I also suspect the reason I'm here is because far more important alumni said no. I graduated in 1998, so it's been a while. I always had a special place in my heart for IMSA. I am the director of the Stem Cell Core at Northwestern University in the Department of Neurology. I got my PhD in biomedical sciences from the University of Central Florida, a certificate in life science entrepreneurship from the University of Alabama at Birmingham, and my bachelor's degree from the University of Illinois at Chicago, so all state schools. My proudest time, though, was when I was at IMSA. I had some unique setbacks in academia. I'm going to talk about that, but the thing I'm most proud of in my life is being a father to my daughter. I want to talk about clouds and rainbows. When I was a young child, I loved rainbows. They were so beautiful, and the more I learned about them, they were so interesting because it was water, and in that water, there was this light spectrum that you could go and show all the different colors, and I loved that idea. Right? And I even had a Care Bear that had a rainbow. I just loved rainbows. Like, they were awesome. So in second grade, when Ms. Modulewski gave us an assignment for science to draw rainbows, I went at it at gusto, right? I know Roy G. Biv and the acronyms, I knew the colors, no one else did, so I was like, oh, this is great. But the weird thing was that assignment was less about understanding how light goes through water to form a rainbow, and more about following directions. So when she said, draw the rainbow, and everyone drew the rainbow, she came up to me and said, Angel, I didn't tell you to draw clouds. And I said, well, you have clouds with rainbows, like they kind of go together. And she didn't like that answer. And she didn't like it so much she failed me. And it seemed very odd. And I remember at a very young age being confused by a science teacher being so angry at someone telling her a fact about science. But I think the other reason, Rainbows are beautiful, but we also like them for what they kind of represent, right? The light, the beauty after the storm, right? And it's comforting because in moments of darkness, we want to know that there's going to be light afterward, right? In times of struggle, we want to know that there's going to be success afterward. And that's also why we like rainbows, because it makes us hopeful and optimistic for the future. The other thing we're kind of interested in is the developmental potential, and as a school, as an institution of higher learning, right? As a pioneering educational community, we want to help foster the development of young minds. And I was fortunate enough to be one of those young minds. But when we talk about developmental potential, we have to ask ourselves, what is meant for us to do with our lives, right? And who decides it? Ideally, it's always nice to say, oh, it's up to us. And it is important, right? The decisions we make are important. But also, the environments that we're in also matter, right? And what does it mean to be undesirable, to be labeled dangerous or a hazard? And this is something as a young child I kind of knew because it seemed in my neighborhood of South Chicago, it's kind of labeled with that little arrow there, right? Historically, after the New Deal, they labeled different areas of the city across the country, and they had a coding system, right? A grade from A to D, right? From the most desirable to the most dangerous and hazardous. And we can still see the effects of that policy today because who wants to invest in somewhere that's undesirable? Who wants to invest in a part of the city, in a building, in a company, in a person that doesn't seem to have a payoff? Right? So I saw IMSA as a new beginning. I came from the Chicago public school system. And I remember Ms. Sharp in my English class told me the only reason she's teaching is for three things: to buy her liquor, her pork chops, and her cigarettes. And she got paid whether we came to school or not, and whether we learned or not. And I'm not trying to vilify all teachers. It's an admirable profession, right? But there are always people who kind of make things worse for others. The problem was she wasn't the only one. There were many teachers who just kind of lost their way. So I saw IMSA as somewhat different. It's a huge juxtaposition. It was taught with teachers who loved to teach, with students who loved to learn, with resources that were never going to be available in my school. But when I got here, I couldn't help but feel different. I couldn't help but feel other. And it was something I never really experienced because, in your neighborhood, you kind of look like everyone else in your neighborhood. And if you lived in a diverse neighborhood, well, there was always some people who looked like you and other people who looked like others. But you all had a lot of similarities because you were all in similar circumstances. Right? So coming to IMSA really meant a change for that. It meant really safety from an environment that was dangerous. But there were costs because I was viewed by some people as dangerous. I never will forget the first IMSAloquium. I was here and I dressed up in a bow tie and I was dressed up and I was excited to learn about the different science that was going on, and one of the parents handed me his garbage because he thought I was a busboy. Right? And I should have worn a bow tie. That's on me. I admit that, right? But it wasn't the first time or the last time that happened to me. Even as a faculty member, till this day, I am often confused with service workers. Right? And there's nothing wrong with making an honest living, but there is something wrong with making assumptions that have no basis in reality. There were other things at IMSA. There were teachers who approached me and said, "Angel, look, I know there's an underground stolen calculator ring at IMSA, and I really need a calculator. For $20, do you think you might be able to find one of these calculators?" And I said, no. And I was really offended, but I also didn't want the opportunity to really make a funny joke go away. So I said, Ms. Yates, I don't know anything about a stolen calculator ring for $20. and there were other teachers who maybe made assumptions about me as well. Right? And sometimes these assumptions just came from a place of ignorance. Other times they just were annoyed. Just like Ms. Modulewski in second grade, they didn't like being challenged or questioned. They saw it as disrespectful. And I can't help but wonder, if I had a different background, would they be equally offended? But it gave me so many opportunities. And I'd be remiss not to talk about some of them today. I want to thank Dr. Richard Dodds, the biochem professor here. Because I think when other, many instructors were kind of saying, he really doesn't try, he saw something different in me. He saw that my ideas were somewhat different than other people, and they were valid, and that some of the ideas I had real merit, that they could turn into patents someday, they can be inventions. And he said, I really see you being an inventor. And one of those SIRs, my sophomore year, I met Dr. Saroja Langavan at Cook County Hospital. And she was in neuropathology, and I asked her, Dr. Langavan, I really like to maybe do some work or do some research. And she said, maybe. And I followed up with her a little bit later, and I followed up with her a little bit more. And I think at some point she saw how serious I was, and she gave me an opportunity. She said, well, I can't pay you, but if you volunteer, I'll let you volunteer and we can do a project together. I said, yes. But I had to support myself financially. What I hadn't told people at IMSA was that I separated from my family, and I was living on my own. I wasn't in the safest environment, and it was better for me to try to figure out how to care for myself. So I did that by working multiple jobs. I didn't necessarily disclose this to people because, well, if I did, it might land me into more trouble. But at Cook County and working with Dr. Langevin, I wanted to develop this clinical mind because I wanted to save lives. And while I didn't necessarily get to save lives there at that moment in time, coincidentally, 10 years later, I would have a chance encounter with my aunt who had a chance encounter with this kid who was actually charged with attempted murder. He was babysitting a child for his girlfriend who went away. And the child got sick. Called the mother, she didn't answer. Calls again, doesn't answer. The kid is sick, so he takes the kid to the hospital. He says, this kid's sick, I don't know what to do. They ask him some questions. The child's vomiting. They take him in. They finally do a CT, and they find multiple subdural hematomas. Well, the interesting thing is that one of the projects I worked with Dr. Langevin was looking at subdural hematomas and the progression of subdural hematomas with time. It's just like a bruise. You have a particular progression of injury. So you could tell the time of injury by looking at the blood, the white blood cell infiltration, the collagen formation. And when my aunt told me about this, she said, I really believe the kid. I said, well, if you believe him, guess what? Get the pathology report. Because it'll tell you, with a reasonable degree of certainty, the area of time that the injury occurred. And if it occurred within a few hours, you're going to see a different phenotype than if it occurred a day, a week, a month previously. And they did that. And it turned out that the injuries happened days before. And they knew this because they can look at the pathology section and they know that this phenotype would not have happened within the 2 hours he had the child and took him to the ER. And I was so happy that there was something that I happened to learn that actually helped someone. I was so proud to be a part of something. I got to save a life. The one thing I wanted to do since childhood was to make the world a better place and to save lives. And I had a chance to do that. And I had a chance to do that because I was eager to learn, and I had that opportunity here at IMSA. My freshman year, I entered UIC with gusto. I wanted to do everything. I was overly ambitious, right? My freshman year, I was elected to be the undergraduate student government president. I was elected to be the president of the Biological Honor Society. I was elected to be president of the Latin American Law Society. I founded the Undergraduate Research Symposium, the idea of bringing scholarship from multiple areas so that students can present their research. Such a novel and original idea. Of course, I modeled after IMSAloquium. And just yesterday, I had, the 24th anniversary. It's been going on since 1999. I was so proud of that, to see something that I did that still lives on. But I had to support myself, and I've been supporting myself since high school. So I had to work 3 jobs. And then you make this Faustian bargain, right? You have to support yourself so it comes at the expense of things that aren't an immediate need, like homework and studying. But that didn't matter because I was so well prepared at IMSA, I didn't really have to study it much. I knew all the material. For the first couple of years, I was able to coast. And then once we did those 200, 300 level courses, suddenly I had things that I couldn't, BS anymore, right? I actually had to read the book. I actually had to go to class. So it was tough because I still had to work those 3 jobs. What I managed to do is I found jobs doing research. I said, well, if I have to work jobs, I might as well do something that's going to help me in my career. And the more research I did, the more opportunities that became available. So I started doing research. I said, look, I want to have a nonprofit biotech company. I want to invent things. I want to invent things and take those patents and turn them over without charge to organizations that can make those things and bring them to fruition and help patients. And by senior year, I was ready to continue my research in stem cells and go off to medical school. And the interesting thing is that my senior year at UIC, I had the opportunity to work in a lab where they were looking at bone marrow stem cells and they were trying to differentiate them into neurons. And spoiler alert, it doesn't really work, right? Because those are bone marrow cells, they're not stem cells. They are committed to a particular lineage and they are very much fixed in that mindset. Just like I will never be a professional athlete. That ship has sailed. right? Well, I thought, well, maybe there was a way that we could change things. And normally what happens in development, stem cells have two properties, right? Perpetual self-renewal, they can keep dividing, right? And pluripotency, that's a fancy word of saying they have a lot of developmental potential to become more than one type of thing. So here's an example. On the left, you can see those pluripotent stem cells and differentiate into progenitor cells, and those progenitor cells terminally differentiate into specific lineages, right? And what happens is that as you become specialized, it comes at the expense of stemness. The more you progress, the less opportunities you have to become something else. So if you want to become one lineage, you are not going to go and do something different. It literally, at the cellular level and at the DNA level, modifies the DNA to prevent it from doing something different. And that's great, because in cancer, we don't have that. Cancer's like, I'm going to do whatever I want, right? But normally your cells don't do that. You're like, no, I'm going to be a doctor. Pre-med, right? Science, research, you're going to do that. You know it, right? Right? So specialization comes at the expense of developmental potential, right? So I thought, well, can we change that by reactivating the cellular pathways that were turned off early on in development? And in 2003, Ian Chambers discovered the gene NOG. And we thought, well, what if we go and re-express this gene and re-express the pathways and genes that were turned off early in development? We reactivate the genes that drive pluripotency. Can we then create a stem cell from any cell in the body? And our results were promising. So I switched. Instead of going to medical school, my advisor said, hey, instead of being a doctor, an MD, where you can save, what, 100 lives? With one discovery in research, we could save the lives of millions. Oh, come on now. That got me. I can't help but think about the Robert Frost poem. Somewhere ages and ages hence, two roads diverged in a yellow wood, and I took the one less traveled by, and that has made all the difference. I like to think every time I reference that poem, like an English teacher gets her wings. Right? Jackie White was the one who introduced me to that poem. We wrote about it at IMSA, and I'm sure that you are also familiar with it. But it's very much like life and like our stem cells. So in 2003 and 2004, we cloned the genes we needed to do, we delivered them into cells, and we went from these differentiated cells to this colony that looked a lot like an embryonic stem cell. And they expressed embryonic stem cell markers, but the control cells did not. I used different vectors, viral, non-viral, that's not important. But then the next thing we do is, well, now that it has this potential, what do you have to do? You have to have it develop down a particular lineage. And how do we do that? We put that in the right environment, right? We don't send them to CPS schools in South Chicago. No, we send them to IMSA, right? And in this IMSA, there's this nice nurturing environment. These feeder cells are secreting these factors. And these cells then become committed and specialized to become what? To become neurons, right? Neurons are a little green. The glial cells, those astrocytes, are in red. When they're kind of on top of each other, they're yellow. It's so beautiful. I was so proud of this. And then a funny thing happened. When I went to present this research at an international conference, I met the Thompson Lab and Shinya Yamanaka. And you know, wouldn't you know it, they were doing something very similar. And imagine seeing someone else do the work that you were doing better than you. You know, it's almost like having someone you're supposed to get married at their wedding and see them with someone else. Yeah. And I can tell you, no, it's actually worse than that. Because now, when I tried to publish, they're like, oh no, that's been done, you gotta do something a little different. I said, what do you mean different? Like, I did this, like, you know, I was here first, like, look at the patent. Like, no, they don't care, right? So, then it was like, well, you have to do more stuff. And you have to do more investment. And at that time, you know, we didn't have the resources anymore. It wasn't worth the investment. It was a hazard. So I had to shift. And I changed now to do that, but also look at cancer. Because in cancer is something interesting. right? Normally you have specialized fate, you make those decisions, you become specialized, and you don't do something else. In cancer, it's the opposite. It doesn't listen to environmental cues. It doesn't do what it's supposed to. It doesn't do the right thing. It keeps dividing, it ignores signals, and it basically activates stem cell-like pathways, and it takes advantage of these developmental pathways to become invasive, to become malignant. And I looked at brain tumors. They're highly malignant, they're heterogeneous, right? It's not one cell that keeps dividing, it's not a clone. No, they're heterogeneous, they're so different, right? They're highly resistant to radiation, right? With aggressive therapy, surgical resection by removing at least 98% of the tumor, aggressive chemotherapy, and radiation, we get to extend life a whole 2 months. That's horrible. I want to change that, and I think if we targeted the stem cell pathways, we would have a way of doing that. So I looked at Wnt. It's responsible for Drosophila wing growth. It's very conserved. Some of you probably know about it, maybe have even presented about it. And I looked at how all this pathway is differentially expressed between different types of brain tumors. So the brain tumor with the same diagnoses could have different phenotypes. I thought that was interesting. And when I took these patient samples, I generated these patient stem cell cancer lines from them. I found when I put them into animals and I looked at how they behaved, they showed this pattern of being either invasive or fast growing, of being resistant to radiation, or being resistant to chemotherapy. They had gene pathways that were expressed in different patterns, right? And they secreted factors that modified their environment. That's interesting because the environment affects the individual cell and the cell affects the environment. Oh, imagine that. Imagine if going down that road, I affected that forest as much or more than the forest affected me. That appealed to me, except I didn't like the idea of being analogous to cancer, so, well, let's move on. There are some interesting things. And then it was time to submit my grant for funding. And a very interesting thing happened. I had a number of setbacks, right? I was so proud before then, but what I found is that I made a deal with my committee. I said, look, I've done more research than any other student who's graduated in this program. I want to finish, and I want to continue my research in Chicago. And they said yes. And then I was in a bad car accident. A drunk driver ran a red light coming off the expressway, plowed into me, knocked me out. I had difficulty articulating my words. I would tell people, like, I have to go to McDonald's to pick up my prescription. Like, what are you talking about? I would go to women who were serving me ice cream and ask them, are you a good girl? And she would look at me really creeped out, and I was like, oh, no, clearly she didn't understand what I was asking. So I would ask her again, are you a good girl? And they would look at me. And my friends would pull me aside. They're like, what are you asking her? And I was like, I just want to know what ice cream she likes. Like, what does she recommend? And like, that's not what you said. And it was weird because imagine you realizing someone is responding in a way that doesn't match the way that they should. It takes a while, right? Thankfully, I don't make those mistakes as much or at all, thankfully, anymore. But that was a struggling time for me, and at a time where I was hoping my advisory committee would be understanding, they weren't. At a time where I would hope that people would be gracious and lend their support and help, there were some people who were opportunistic and decided, what a great time to plagiarize Angel's work. What a great time to take his grant that he wrote and submit it with my name on it, with someone else's name on it. And how weird it is to be recovering from an accident and see an announcement for someone getting an award for something you wrote. And I'm like, wait, how bad was it? Maybe, am I dead? Because if I am, I know what place I'm in. And academia is not the most forgiving place. It's analogous to almost professional athletes, you have a very short time to demonstrate your worth. A very short, narrow period of time. If you get injured, your junior or senior year of college, professional sports teams don't want to take a risk on you. You're too dangerous. You're a hazard. You're not a good investment. So it affects me, right? I have probably a dozen patents nationally, multiple pending and international patents, and it didn't matter. It didn't matter because some people saw that I wasn't a good return on investment. Like, well, we don't know what's going to happen, right? You have to write grants. In order to write grants, you have to have grants. I was like, well, how do I get grants if I don't have grants? It's a chicken and egg thing, right? So this interesting cycle, why people leave academia, right? You have this thing of working hard, you get this momentary bliss because you accomplished something, right? And then you try doing it again, and then you have some new challenge, a new disappointment. It's not for everyone, right? So if anyone was thinking of grad school, well, reconsider this, right? Heed my warning, right? And if you're like, hey, look, I know this, but I still want to do it, well, good luck, right? It's a great profession, it's noble, but it's not for everyone, right? And one thing I want to warn you about is in academia, they have this 3-strike culture, right? 3 strikes and you're almost out. They make the barriers so hard that it's difficult to overcome, right? If you're from an underrepresented group, right? If you don't look or act like others, if you don't have the same pedigree, right? If your parents aren't academics, you're different. You don't fit in the culture. It's harder to network. You don't know what to do. That's strike 1, right? If you have a setback, if you get injured, get sick, if you have a child and you're the primary caregiver, that's strike 2, right? And if you don't have support or resources, well, that's strike 3. And this is where people really can help each other out. We have to lift while we climb, right? It's easy to say, oh, look at this person. They have all these awards. Let's go and help them. That's great. That's a sure thing. No one's going to question you for that. But to say, hey, this person, they have potential, that takes guts and that takes risk. And the weird thing is that it's people who don't have the traditional backgrounds that make the most interesting discoveries. Everyone else who've trained the same way are going to do the same obvious things that everyone else like them is going to do. It's people who come from different backgrounds, who have different experiences that can look at the world in a different way and come up with something unique. Right? So you're going to encounter setbacks. They're upsetting, right? It affects your productivity. You build up a reputation. Oh, tragedy always, follows this person. Not their person's choice, right? And we underestimate its effect on us, right? But there's positives, right? I don't see a person who's like trying to balance, raising a kid and doing their work as a negative thing. This person can multitask. This person has to be organized, right? This person knows about prioritization. They can look at different perspectives. They have resilience, right? But it's also important to run your own race. Don't compare yourself to other people, like within reason, right? But be realistic in your expectations, right? Be aware of your feelings and your emotions and what's healthy for you, and seek out support when you need it. And you have to ask yourself, what will make you happy? If you're not happy with yourself, the external validations aren't going to change that. There'll always be another grant. There'll always be another job. There'll always be another opportunity that you will want to get because you aren't happy with where you're at right now. So I'm at the stem cell core. I won't bore you, but one of the interesting projects I want to kind of end with is this project I'm working on looking at endometriosis with the collaborator, Julie Kim. Endometriosis is interesting. It affects 10% of people with uteruses. It's one of the primary causes of pain, and we know very little of it. In fact, what's interesting is that we know more about male pleasure and arousal, down to the neuron, to the receptor level. And we know absolutely nothing about how to treat pain in women. So I thought, well, we can maybe change that. We can take these stem cells that have this great developmental potential, we can differentiate them into the different cell types that make up the endometrium. We can make these organoids that model the cellular hierarchy in tissue. And we can look and we can culture them with neurons, those little green dots that you'll see. And we can see how these neurons behave in this tissue. We can see how the environment affects the neurons, how the neurons affect the environment, right? And I want to ask you finally is, what determines your potential, right? It's not just the choices we make, it's also the environment that we are in. And that's why it's so important to not just focus on your own development, but also the development of others. And I know IMSA has helped me with that. And I want to thank the people who've helped me. And even though it was not always the most positive experience, I am a better person for it. Thank you for your time.
Thank you so much, Dr. Alvarez, for that wonderful, inspirational talk. At this time, I'd like to ask all the SIR participants to go over to the gym and be ready with your posters. Okay, so, and we'll see everybody there. Thank you so much. Thank you, Dr. Alvarez.
Oh, thank you.
Really, really good.
Thank you.